Hola. I think so. Hola. ¿Cómo estás? That's all the Spanish I know. I'm sorry.
Eso sería todo el español que sé.
Thanks for having me today. I'm really excited to talk to you about this topic and go first here because I think it's a good way to sort of introduce this conference. I'm going to talk about how memory works. I'm going to talk about how to improve our memories, and I'm going to talk about how to improve how you teach other people. So I hope that you can take some of these concepts throughout these next few days and really implement them in your learning and in your teaching. So as we just heard, my name is Yuna. You can find me online at UNA. That's GitHub, Twitter, CodePen, any of the things. I also have a podcast called Toolsday. It's Toolsday, where I talk about tech tools, tips, and tricks, mostly on Tuesdays. So you can check that out if you want more technical information. But this talk is going to be more about how we learn. We optimize all the time for our JavaScript, for our application software, but we don't really think about how to optimize how we're learning and how we're teaching these things. So I wanted to give a talk about this subject today. Let's start with Redux. Who here has heard of Redux? Okay, that's about half of you. Maybe less even. Who here uses Redux in their work? A few people. So Redux is a pretty technical concept, right? It's pretty technical, or at least it sounds that way. The fact that it's a state management system also makes people get nervous. Like state management, I can't even manage my own schedule. What does that mean? According to the website, Redux is a predictable state container for JavaScript apps. Here's the gist. It's what it says on the website. The whole state of your app is stored in an object tree inside a single store. The only way to change the state tree is to emit an action, an object describing what happened. To specify how the action transforms the state tree, you write pure reducers. That's it. Got it? If you look further into the documentation, it even says, it starts off with Redux itself is very simple. And it's true once you understand the basic concept of what it is. But when you start looking through this page, it doesn't really seem that simple right off the bat. If this was your first time diving in, other than the code samples, there's not a lot here helping us to understand this content. And this is even a good documentation page in comparison to a lot of what we see online today. But it's still just a page of text. Does anybody ever feel this way about documentation sometimes? You get excited to dive in, and then you open the docs, and then all the time. But now let's take a look at another way of explaining Redux. Okay, so Redux is a state management system. As you can see here, an action is invoked on the site. So there's a proposal, she says yes. Then that action speaks to a reducer, so here we have our reducer Robin, who knows the language of nature, who can then convey that information in a language that the state tree can understand. The tree is also the store, which then updates the knowledge and the state of the application, or the state of the world. So here it's setting the information for this person, Mark, to status engaged. So this is a little bit non-traditional, and it might have a few technical gaps in explanation, but it's a lot more welcoming, and it's more intriguing, and it's designed to help you understand what's going on and want to learn more. It helps you to learn a concept. There's a metaphor here that the user can relate this to that's not another technical metaphor. You can't compare language to language here. So from then, this user can dive in and learn more about Redux to get started. Most modern development concepts really aren't that complicated once you dig in. They just appear complex because most documentation sites are just intimidating blocks of text. Nobody likes to read big blocks of text. It's just what we're used to. It's how we were taught growing up. But we can do better. So in this talk, we will discuss the psychology behind memory and understanding, creating effective documentation and tutorials, tips for basic schematic modeling, for basic diagramming, tooling, so some tools and websites that you can use to help you make these diagrams, Examples of how diagrams can improve outcomes for your users and also for yourself, for your internal comprehension, how you understand a subject. And then finally, we'll talk about the benefits of doodling. So as was previously mentioned, this is a project that I started a few months ago called Doodles. And you can find it on Instagram at dev_doodles, or you can go follow me on Twitter, where I also link to Doodles pretty frequently. So it's a series of mnemonic devices and illustrations of technical concepts that tries to show this concept that technical diagramming doesn't have to be boring. Documentation doesn't have to be boring. The doodle in the first example that I showed is just one of many that I've worked on as a means of even helping me understand some of these concepts and then teaching those to other people, so sharing how I remember them. Here's another example of one of them. This is the spread operator. So the spread operator is ES6, so JavaScript syntax that allows you to use the apply on elements without needing to bind a context to them. So if you use it with a string, it kind of works like this. You can use a spread operator, which is the 3 dots, ... and a string. It spreads it out. So here I'm spreading it out into an array. So I imagine it like a spelling bee. So if you have these two people and you have a variable, which is a string, coyote, someone's saying spell coyote, and someone's saying ... So I remember the spread operator with the ... And then when you spread it out, you get COYOTE, like a spelling bee. They spell it out. So this is technical documentation. It teaches the same concepts, but it doesn't have us feeling like this all the time. So, I love that GIF. So let's start with perception and memory. With all the things going on in our field, it's hard to remember all of them. I wish that I could just absorb information and remember it, but there's so much going on. How do you decide what you should be focusing on, what you shouldn't be focusing on, how to remember those things? I want to take a look at a very short video. That's a 2-minute video. It's an overview of how we remember things.
How does your memory work? Your memories are interesting to think about, not just as sticky situations from your travels that you always tell people about, but what's going on inside your brain. Because every time you remember something, your brain calls on your memory network, and instantly, the hippocampus and other parts of your brain spring into action. They work together as a crack team, building your memories from scratch. Whenever you witness an event, learn a fact, or experience something you really want to remember, these parts of the brain kickstart the memory-making process. Here's how scientists think it works. First, your brain consciously registers the memory, a process called encoding. If you're like most people, you forget a name right after being introduced to someone. This doesn't mean you have a bad memory. It means that you haven't encoded the name, probably because you weren't paying attention. The next step in the process is the glue that holds the memory together. Scientists call this step consolidation. But the memory is only a memory once you remember it. Which is why scientists call the final step retrieval. And retrieving a memory is actually one of the best ways you can boost your memory. Because every time you remember something, the neural path to that memory gets stronger, making it even easier for you to recall it again and again. But there's even more that you can do to help your memory. And it's not rocket science. A regular sleep pattern helps. So does a balanced diet, which not only keeps your body in shape, but gives your brain the vital nutrients it needs to perform. Exercise helps too, by boosting the amount of oxygen and nutrients flowing to your brain. And finally, challenging your brain. Learning new things and staying mentally active can actually increase the physical size of your brain. All of these things will keep your memory on its toes, which means that you play the starring role in maintaining a healthy memory, and that it's actually you that makes your memory work. You and your all-important memory network.
So I really thought that was a very cute video to kind of demonstrate how memory works. The things that they talked about at the end of the video aren't the only ways that we remember things. There are a lot of little tips and tricks and techniques that we can use to help us encode things into our long-term memory. So if you remember, there are 3 types of memory. There's sensory memory, there's short-term memory, and there's long-term memory. And this is an example of sensory memory and how that works. So sensory memory relates to our human senses. So olfactory, which is how we smell things, there's feeling, there's visual sensory memory. So this is an example of that visual sensory memory, and it shows how fast that decay rate is. So it's a diagram showing that if I was on stage here spinning a rope, if I was to spin it faster than our sensory memory bank, it would look like a complete circle. I'm sure that we've all seen these. If you spin it really fast, a rope, it looks like, to our brains, it's one big circle. But if you spin it slower than that, if you spin it at 120 milliseconds, you see a gap, and that's the sensory memory gap. That's where we're not connecting the dots in our brains. So that's the first type of memory. The second type is short-term memory. So there are studies that have been shown that we can store in our short-term memory between 5 and 7 items. So I'd like to give you 10 seconds to remember this number. Okay, got it? Really got it? Now, what was the 4th digit? 9, yeah. A lot of you got that. It was 9. When you were trying to remember the 4th digit, though, did you start reciting the entire sequence in your head? Did you say 5, 5, 8, 9? That's how we store short-term memory, and that's how we retrieve items in our short-term memory. It's sequential, so you have to go through the whole sequence. Now that's different than long-term memory, which is the final type of memory, because we encode those things and then retrieve them without having to go through a sequence. This is what we hope will happen when we're going through tutorials or dev videos or blog posts to kind of try to remember all the technical concepts out there. Does anybody ever wish they could be Kirby and just absorb all of that knowledge? Like instead of food, these were all programming tips and like algorithms. Like if this was service worker syntax, I could just absorb it. How cool would that be? But it's more like this most of the time. Long-term memory is stored and retrieved by association. So the benefits are that we can retrieve it by a variety of different means. We might discover a bug that reminds us of another issue that we had, or an architecture challenge that we know how to begin to face because we remember scanning a blog post about something similar topic. So there are 3 main ways in which information is encoded into long-term memory, including visual and acoustic imprints. But the primary way to encode information is semantic meaning. So that means that the best way to encode things into our memory is to really understand the meaning of it or to relate it to other things that we know. As the video showed, the more that we repeat specific information, the more likely it is to eventually end up in long-term memory. So that's why things like studying or having more code experience in your career help us perform better as engineers. People also tend to more easily store material on subjects that they already know something about. And that's because it's easier to form mental connections between items that already exist than to create brand new spots in your brain for slots to remember items. So we can't all know everything about everything in the world, but we can learn a lot about a specific subject. That's why we have experts that emerge in certain fields. Again, most of the time when we forget something, if you don't remember somebody's name, it's because you really weren't all that focused in the first place. This happens all the time. It's really common. We get distracted or we weren't paying close attention. So it's really important to try to focus when you're trying to remember things. Maybe write them down, maybe repeat them as you're learning them. Human beings, being primates, are visually dominant animals. We dedicate a large part of our cortex to processing visual information. So as you can see here, the green part in the back of the brain is our primary visual cortex and visual association cortex. Next to that, moving forward, is our reading center. It's a lot smaller because it came later. We learned to read a lot later than we learned to see, right? That makes sense. Names and even written language, and especially code syntax, are all human constructs. They're things that we made up, but vision is something that we've used for survival that's been developing as a part of our human anatomy for far longer than this idea of reading or our ability to understand written language. The first written language was called Sumerian, and it was a purely logographic language dated to around 5,000 years ago. So according to sources on Wikipedia, there are studies that suggest that spoken language evolved around 350,000 to 150,000 years ago, around the same time that Homo sapiens evolved. So language existed before our version of human species was even developed. But we've only had written language for, at the most conservative estimate, 3% of that time. So again, I ask, why does most technical documentation look like this? It's an easy default that we're accustomed to, but it's not the best solution. Because there are a lot of different ways to learn. There are 5 common learning modalities that all correlate to our senses. So that there's visual, auditory, read-write, olfactory, and kinesthetic. So it's smelling and feeling. When we try to pigeonhole everyone into the same learning style, which is often how the school system works, it's detrimental to individual success. If someone isn't good at reading text and memorizing, we create this inaccurate idea in their heads that they're just not smart because it's just not for them. And that leads to having people with similar styles of learning in the same fields, like tech. The way that we share information could be a contributor to why tech has such a diversity problem. Even with language, having English as a first language is a huge advantage in tech. Everything is written in English. All the blog posts, a lot of the videos. I'm giving a conference talk in English. This is what people do. And it's not fair, and it's something that I know a lot of you have faced. It's a really big challenge. So if we try to mix in some of those other modalities of learning, maybe visuals, etc., that could try to break down some of those barriers. But right now, what we're doing is we're creating this technical monoculture, this information bubble for people who are good at reading and writing in English. Those are the people who are excelling at tech, and that's not how it should be. But what if we diversified how we share information? Who would be interested in tech? And building new applications and hardware, and building different kinds of applications for people to use in different ways? What other skill sets will we be bringing to the table to improve our products? What's universally true, regardless of what kind of learner you are, is that combining multiple modalities helps anyone to learn. So in your work, try to combine as many of these as possible. And if we go back to this idea of how people evolved, not only was vision something vital to our survival, but audio was too. If you saw something lurking in the bushes, you would use vocal communication to tell your tribe mates that there was something there. That's why web animation is actually so effective, because it triggers that primal part of our brains that sees something moving in the distance in our peripheral vision, and it makes us react. We have stories and fables that far predate our written language, things that have come from our ancestors, and not much has changed. We're still the same. Sorry, this is dark. Oops. If we look at that brain visual again, we can see that there's not one, but 3 different regions of the brain that are related to auditory input for low, mid, and high-pitched tones. And there's a whole separate region for speech input. So humans are much more adapted to retaining information via audio than via text form. And I didn't realize that I was an auditory learner until I started listening to a lot of podcasts, and I learned a lot that way. I was able to retain information better that way. I do think a lot more people are auditory learners than they realize. A lot of people haven't tried it yet, but I really would encourage people to try that, just because our default is not something that they're used to. So this realization, along with wanting to create a more accessible experience, is the reason that why, for my personal blog, una.im, I started recording all of the blog posts audio. So that way people have an option. They can read the blog, they can listen to the blog, or if they really want to grasp the concept and focus, they can read as they listen. And people really liked it. When you make an experience more accessible, it improves that experience for everyone. And while not everyone uses a screen reader and not everyone is an auditory learner, everyone learns better when there are options, when there are a combination of sensory modalities, and when they can choose how they want to learn that subject. So here's where we'll get into some examples of making technical diagrams and illustration. Vaidehi Joshi is someone that I really admire. She does a lot of posts about computer science concepts, and this was a post about insertion sort that she wrote, where she included a variety of mediums here, from hand-drawn notes to GIFs, explaining this concept of how insertion sort works, and it was just a lot more interesting to read this page when you had a variety of media here. It lets our eyes move throughout the page, absorb information, and really scan things. I'm sure you've heard the concept, a picture is worth 1,000 words. A GIF is worth like 10,000, because you might have 10 plus frames in there. So visual aids and having a variety of visual aids is super helpful in not only getting information across to your users, but also to help your users stay engaged and stay on the page. There's so much out there that we're fighting for in this attention economy of the internet. So this will definitely help with that. Let's break down some of those and talk about the visual aids. You can see here that layout A is much harder to scan than layout B, because layout B uses a few different techniques here to help people feel more activated. It uses hierarchy, callouts, you're breaking down this content, you're chunking the content into small areas of text. That really helps people absorb and scan the information. And you have a variety of media here, including videos, bullets, that's a different layout type. You can have images here. There's a lot of different ways to do this. So you can have illustration or diagrams, like I mentioned, video. Interactive code samples are really great, especially for documentation. Typography styles, the size and color, you can play with white space, you can play with layout. And then again, those callouts or sections, the aside notes will help your user understand what's just a little comment or a link for more information. And images don't even technically have to be traditional images. Emoji are a great example of creating emphasis with minimal effort. Emoji can make certain text stand out. This is a premium feature for Twitter that brands can pay for. It's an example of bringing attention to a topic by combining image along with text. You're introducing a visual pair. And those two inputs create this visual cue of imagery that keeps our brains activated and noticing that text along this little sea of other tweets and text. So I love seeing emoji in Git commits too, because it helps you to visually parse and understand information. Adam uses this key when they're writing commit messages. This way, when you look in their log, you can see when bugs were fixed, how many, what type of feature they followed, and you can see how many of like a certain type existed in a range of space. So we can see when tests were added or performance was improved just by parsing this to see an icon. If this was a wall of text without icons, it would be much harder to parse. So introducing iconography into your commits could make them much easier to read and work with. And this is especially true once you get used to a system and your team gets used to working in the system. So let's talk about some diagramming tips, combining these things. I first want to talk about symbols. How many of you know what Monopoly is or played with Monopoly as a kid? A couple of you. So this is a pretty popular game in the US. Pretty much everyone who sees these symbols would recognize them immediately as, oh, those are the classic Monopoly pieces. So having these sort of universal symbols is a way that we can help make our diagrams and illustrations more accessible. In the dev world, there are a few iconic pieces that help represent cross-culturally a few items on the web that we can use for basic diagramming. And these include these universal UI symbols like home, hearts, that symbolizes like or favorite, refresh, making things larger or smaller with those arrows, downloading, battery indicators, settings, menu icons, your hamburger or your kebab menu. You have two choices. So these are things that we can use as just basic elements in our diagramming. When you do use these common symbols, pair them with the right color. So choosing color along with the symbols makes more sense. So if we have a check, make it green, and X, make it red, make sure that you're also including symbols, not just color, for people who might be colorblind to make this accessible. But the one thing I want to say here is don't collide this color. Like, this makes no sense. This makes no sense. Why did the Windows Phone did this? And they got a lot of flack for it, for having their call button red. Why would you do this? It makes it so much harder to use. So just be color conscious when you are diagramming. And I'm sure that this kind of image is something that we're all pretty familiar with. It's a weather map. But what I want to point out is how it's annotated. So the important bits here stand out with labels and arrows showing directionality. Annotation is something that we can use in the dev world. Sean Larkin is a really good example of this. So Sean Larkin is working with Webpack. He really wants to make it more accessible and understandable for people to use. So in the same way that you can annotate the weather, you can annotate code. And I was talking to him about how he does this and why, and he was saying that with annotation, with drawing on your code, you can really pull together areas of information. You can use color to describe matching areas and arrows to show where they're related to other parts of your code base. You can't just do this with comments. Comments are linear. But annotations are dynamic, so you can use them to help your users understand, to help explain something to somebody else in your team. It's a tool that people don't use that often. So here's another example from Sean of him taking annotating to another level, combining it with illustrations, visual plugs, and arrows. Arrows are really powerful in diagramming. They're like icons and arrows is all you need. With arrows and just icons, like emoji alone, we can show step cycles. So maybe the triangle needs to be isosceles and not right. We have frowning to smiley. Here we have another symbol of directionality, cause and effect. We have directional flow. So with just a simple arrow and some emoji, you can convey a lot of meaning. So don't let diagramming intimidate you. It's mostly just boxes and arrows. This is just arrows and icons. It is a diagram of Game of Thrones. And if you haven't seen the last 2 seasons, close your eyes. It's spoilers. But this shows all the relationships between all the characters. Who is related to who killed who is royalty in this world. And it's really concise. It shows all this information in a small, simple diagram. This is 4,228 pages of text in a diagram. All of it is distilled. We can parse it in a few minutes. And we can reference it. There's no way to go back through these books to reference something if you don't already know the answer. So simplicity is key. This is a flowchart that illustrates a basic GitHub merge workflow. Flowcharts can help us to architect and think through our products. And they just require a few basic shapes and arrows. Just a few basic shapes. Those shapes are ovals, arrows, parallelograms, rectangles, and diamonds. You have these ovals that are your start and end. The arrows show directionality, and on the arrows you can also have your text, so that could be decision statements. The decision statements are the diamonds, so that is a decision that you're making. There's your inputs and outputs, that's a parallelogram, and then there's your process, which is a square or a rectangle. So if you know these 5 basic shapes in your team and you share this process, you can start making things like this. And this is how Slack decides to send a notification. I pulled this from Twitter, somebody shared this from the Slack team, and it was just so interesting to find this really complicated concept of how do we decide to send a notification or not, distilled into one flowchart. When you understand what those different icons and symbols mean, you can read this whole thing very easily. At DigitalOcean, where I work, we have a pretty big community with blogs that's really aimed at developers and not just sysadmins. And my product that I work on is a cloud infrastructure provider. So because of this, because we want to have developers be able to use this themselves, we have a lot of diagrams in our blog posts and tutorials that really try to combine visuals with text to help people understand what's going on there. This is an example of a production server setup. So we have a load balancer combined with a database server with monitoring, logging, and backups. And that's a pretty robust but standard system. So in a lot of situations, having a diagram is worth 1,000 words. It lets people describe this text of the entire article without having the text itself. And when you can explain something in a consumable manner for anyone, it improves the experience for everyone. Subtle animations can really help too to bring flow and visual attention to a concept. This is a visual of how load balancers work. It's one of DigitalOcean's products. So here you can see that we have these 2 floating IPs. We're looking at these primary and secondary load balancers. If one is down, if I play it, then you'll see. So it goes through, it's active, it's healthy, but if it goes down, then you have the floating IP switch to the other load balancer, and it sends it to the second app server. So again, this diagram, a small little GIF, can explain an entire article of how load balancers work. DigitalOcean even has icons and a style guide for creating these kinds of applications, which I love. So if you have an API or another product that has a lot of documentation and would benefit from diagramming, or if you have a blog, a technical blog, then I would consider working with design to create a few elements that you can use in cases like this. So let's talk about some tools. That last example with the elements that you saw uses this tool, draw.io. This is a website. You can also download it and use it locally. It works offline, where you can create charts, flowcharts, electric circuit diagrams if you're into Arduino or Raspberry Pi or electronics development. You can create maps and tables and a variety of different graphing techniques. So it comes with the basic shapes as a set and some basic coloring tools, and it's free online. You can use it and work with it locally. OmniGraffle is another really popular tool among UX designers. A lot of people on my team use this, and I see it, and I'm like, ooh, what are all those buttons and arrows? If you do use OmniGraffle, there's a great site called Graphletopia that has a lot of free stencils. So on the left, you see the Atlassian UI stencil kit. In the middle, you see mobile prototyping interactions, so like mind mapping tools. And on the right, you see some web UI basics. You only get one download a month unless you get a pro subscription, but here's a pro tip. If you share a stencil, anyone who shares their own stencil gets a free Graphletopia Pro account. So if you contribute back, you get a free account, and you can get as many stencils as you want. Another awesome free tool is called ASCII Flow. It's super basic, but it gets the job done. And you can export to ASCII, which makes it really good for documentation. So you can copy and paste this in your READMEs. And like, again, this is just text inside my presentation that I can copy and paste. The next one I want to talk about is called 53 Pencil. Pencil is the app of 53. And they recently got a bunch of diagramming tools. So if you have an iPad, you can use this to just start drawing, and it makes like a perfect circle or a perfect square or rectangle for your diagramming needs. So we talked about diagramming a system for other people to use. We talked about some basic elements and how to diagram, and we went over some tools to help you build your own diagrams. But now let's talk about diagramming for your own personal comprehension. I've learned that whenever I create a diagram for my own comprehension, it 100% of the time helps other people as well. The more knowledge somebody acquires about a subject, the harder it is for them to relate to newbies, people who are new to the subject, people who are learning it. So it's important for us to take a step back and try to think about the perspective of your audience. Who here has less than 3 years of experience in development? Nobody? You're all experts? Well, for your peers and your colleagues, I would recommend that you give the advice of them to start a blog. If you don't have a blog yet, start a blog, start taking notes, build a presence, start sharing those notes, begin experimenting with some of the emerging technologies, and be a teacher. Because you learn as you teach. This is really important. I think I've learned so much by doing conferences, by mentoring people in my community. We need developers who aren't writing the frameworks themselves to help with the documentation, because they understand what's important and what's not, what holes might need filling for somebody else who is just in their shoes trying to learn that. We need newer developers to be writing blog posts and to be producing educational content and to be contributing to open source, because they're much more relatable than people who are writing the frameworks. So again, I would really encourage you to start sharing and educating as you're learning. Diagramming systems is also a great way to discover bugs and inconsistencies. So this is something that I created for DO, which is why I can't actually show it to you, but it's pretty and colorful. It's a good way to see if something isn't fitting right. This is the diagram I created to show all the event flows at DO from my own understanding. And it's really helped a lot of people, including senior engineers who've been at the company for a long time, to really understand the system better, because it's constantly changing. So diagramming entire system diagrams, system architectures is really great. I would highly recommend it within any company, especially if you work in a more complex product. And again, it's a great way of seeing if something isn't fitting right, if something could be improved. You can really improve your performance of your application by just drawing it out. There are a couple of mnemonic devices that are also a great way of helping you remember concepts as well. A mnemonic is defined as some device which aids the memorization of something else. And there are 9 basic types I'll go over pretty quickly. There's music, so a jingle. A way to remember something is just to create some quick lyrics to it. Names, like Roy G. Biv, that's how I remember the rainbow: red, orange, yellow, green, blue, indigo, violet. Expression or words, like PEMDAS for the order of operations, like parentheses, exponents, multiplication, division, addition, subtraction. There's models like food pyramids or plates or other visual diagrams that people have memorized or learned a lot as children. Odes or rhymes. So there's an ode or rhyme that is a way to remember a date. Notes or organization is a mnemonic device, so like note cards or relating information. Images, so you can have image association in your notes, or visual ways to remember certain concepts by including them in the words. And then speaking about the words, you can make connections with letters, like Longitude has an N, so longitudinal lines go north to south. And then spelling. There's a river in America called the Mississippi River, and it's really hard to spell, so we created a rhyme type thing. It's like M-I-S-S-I-S-S-I-P-P-I. And then you have contests to see who could say it faster, and like that's really cool. Anyway, mnemonic devices are a great way to try to combine with our technical concepts to remember concepts and then help other people learn them. So speaking of mnemonics, I was recently on Suze Hinton's Twitch stream, which is really great, by the way, if you're interested in electronics and JavaScript. She has a Twitch stream every Sunday where she talks about those subjects, and it's just like live coding, and it was a lot of fun. But she taught me about anodes and cathodes and differentiated how the two were different, so which one had the longer or shorter lead. And so I created a diagram while I was on the show. The mnemonic of anodes that we learned was anode is A+, positive, like longer lead, reaches for the stars, is a better student. And then the cathode is the shorter one. It's like the C-, like do better in school, kids kind of grade. But mixing code with this diagram and having these mnemonics and just creating a visual interpretation of how to make an LED blink was really, really helpful for me to understand it. So this is literally how to make an LED blink with Fermata Party and Johnny 5. A couple lines of code, that's all you need. And then I shared that, and it really helped other people too. Here's a tweet that says, just tried it, awesome stuff, as easy as it looked. I love hearing that making an LED blink in Arduino for someone was easy when they saw this one diagram. So if you can explain something in this short chunk, do that. Don't make people read entire blog posts. Here's some more examples of how mnemonics help with comprehension from the DevDoodles account. This is an example of the promise API from JavaScript, which is new with ES6. So I have this IOU scenario where you're promising to pay rent. You have this rent promise, and then you fetch the link to your rent money. It's like, oh, I have to go get the rent money. So that will return a promise. It doesn't return the rent money. So you have this IOU, that's the current state of the promise. And then once you get it, then you can have this then statement return, and you can update the data, the rent paid, and you can have the information there. That's what you're passing. You pass the data. Or if you don't get it, then you have this catch statement where you send a warning. So a little visual of how promises works. The way that I remember map is by using that mnemonic of word association. So the way that I remember array.map is morph the array piece by piece. So here I have an example of, I have this array, my array 134 is the items in it, and then I do my array.map, and here I have the transformation where I take the value and I morph that value piece by piece. Each piece of the array is getting morphed to create 2, 4, 5. So just one way to remember what I'm doing with an array.map. And then finally here, for in and for of loops. For of loops are awesome. They're so helpful. When you have a for in loop, what you're doing is you're saying for let pet in pets, this array of pets that I have, you're going to return 0, 1, and 2. You're going to return the index. So for in loops give you the index. If you have for of loops, like for let pet of pets, you get the object itself. So you will console log all the pets. You get Lola, Mandy, Rex, the pets that I have in the index. So for in is index, for of is object. It doesn't always have to be an object, but it kind of helps you get the idea across versus for in. This is what I want you to really internalize from this talk. Helping humans understand is a part of our jobs. A part of our jobs is expressing our work to other people. No matter what you're doing, at some point you are working with another human. You're building for humans. That's what it comes down to. Without that, like the impact that we have is limited. Without the ability to communicate, we're going to be reliant on other people to get the word out about our product. And we often don't have the privilege of working with technical copy editors and with developer evangelists to push our product. It's usually up to us, even internally. So understanding how humans understand is a really good skill to have as a developer. Again, going back to that idea of brevity, I started to convert some of my blog posts about how to use different image effects in CSS into just images. So last week I was on an airplane and I drew this duotone effect with images in CSS, and like this concept could be an entire blog post, but it's a way to do it in a single image here. So you have the before and after state, you have 2 mixed blend modes, darken on the highlights and lighten on the shadows, and then I shared a demo with this. So image plus demo, that was it. You don't have to read any text. This is an even more complex example of how to combine blend modes and cancel them out to create a 3D image summed up in a single graphic. So you have these two blend modes that you're applying as lighten, and then you overlap them and you apply darken or multiply on the top layer, and then you offset the layers, and the layers that overlap, you see the true color of the pixel behind them. So I'm working on trying to break some of this stuff down into smaller chunks. A last example of how illustration kind of works as blog posts is this illustration for something I'm currently writing on image optimization. And this is a technique that involves reducing image contrast to reduce the size of your image, and then reapplying that contrast in CSS using CSS filters in the browser. So you save like 30% of your image by doing this technique. But now this image will be in the blog post. You have it combined with the text. People can share it if they want to add on to it or do demos or tests about this. People can see exactly what's going on here. So brevity is key. Do note, if you are using this approach, be sure to have alternative text for screen readers and also captions for translation. So have the image but also have your alt text. You can also use diagramming to help keep things straight and create a shared language. We forget about note-taking, like taking out a notepad in front of you and writing things down as you learn. There's a reason we did that. So, like pick up a pencil and paper and write it out. This is an illustration I drew about testing types, so unit testing, end-to-end testing, integration testing, and how they all differ, with an example of each, like examples from actual unit tests, end-to-end tests, integration tests at DO. So that leads me to doodling, which I'll briefly talk about. Doodling helps you to think through, understand, and remember concepts because the physical act of writing is actually more effective for memory retention. It's a shorthand way to form connections between concepts, both physically on paper and mentally in your mind. So sketchnoting is a really, really good example of this. I want to show you some really good sketchnoters that you should follow on the internet. The first one is Chiku, and she was at a talk by Amy Weibo, and just started to create this visualization of her talk in a way that's really nice to look at and effective. Speaking of Amy, Amy does a bubble sort zine where she creates these little zines of computer science concepts and puts them out. So she sells these, and they're really great. I get this zine, and they're really fun to read. They're short. Susan Lin is another really great sketchnoter. Kosmari, so this is Mariko's account. Mariko creates these really nice illustrated guides to technical concepts as well, and she currently works as a developer relations person at Google, where she's doing more of these talks and illustrations, helping people understand how the web works. So one thing that she actually did was read textbooks and translated those textbooks into these easier to understand illustrative diagrams, so I really respected that. Finally, Lynn Clark is amazing, and she creates codecartoons.com, where she takes JavaScript context, like Redux and Flux, and explains them with cartoons. So if you haven't seen that yet, check out Lynn Clark's work at codecartoons.com. When you write, you learn. When you learn, you can teach. And when you teach, you reinforce and rethink concepts. So doodle for yourself, if for nobody else. And again, even if you think that you're not good at drawing, still practice. Nobody has to see it. And the more you practice, the better you get at it. So don't be afraid to take handwritten notes, and don't be afraid to doodle, and don't be afraid to share those notes. So some final little doodle tips and takeaways. When it comes to diagramming, I think one tip that people usually go like, oh, is when they think about how code looks like. A code placeholder is just indented text. And there's just a few different shapes that you can use to create different elements on the browser. So use doodling and diagramming to learn and teach. It's a really good learning tool for yourself. Brevity is key. Keep it short, keep it readable. Use imagery paired with color and basic symbols. That's really all you need. Arrows and boxes are often all that you need there. Take notes again by hand. This could be a really effective way to remember things. And then finally, share what you've learned. So I hope that you've gained some inspiration from this talk for the rest of the conference to start taking notes, start thinking about technical concepts in a little bit of another way, and then to share what you've learned here with all your peers. Thank you.
Thank you, Yuna. Pasamos a las preguntas. Tenemos cerca de 10 minutos para hacer preguntas. Recuerden que la pregunta la pueden hacer en español.
You hear me okay, Yuna?
Yuna va a tener traducción simultánea. Así que,
We have simultaneous interpretation for Yuna. Yuna, can you hear me okay? You hear? Okay. Questions? We're open for questions now.
Preguntas por acá.
Any questions? Using the mic, please.
Feel free to ask me anything.
Pregunten lo que quieran. Hey, over here. Gracias. Gracias por...
Actually, it's not a question, but like another example. There's a series of books that names Head First, which has a lot of topics about programming, like Head First JavaScript or design patterns. Just like an example.
Oh yeah, so there are a lot of great books on the subject. I personally really like A Book Apart because they're really short and they came out with ebooks recently. I have a really short attention span. So like my podcast that I do, it's like 25 minutes. That's the limit that we try to keep. So when you have a shorter book, I tend to be able to keep with it a little bit better. So I would recommend the A Book Apart series. There's also some really good books that are coming out just by individual authors. Tutorials are really good. Like Wes Boss's course is, I think, a really good one for learning Node or for learning React. There are a lot of tutorials out there and courses. Egghead.io is a good one too because they have like these 3 to 4 minute videos that I think are really effective. And then you can use them as a reference. So if you need to look up something while you're building, I think that's the most effective because if you read a textbook, you'll retain some of the information, but not really all of it. But if you start to build and then look up things in that book while you're building, it'll be a lot more easy to remember because you're relating it to something else.
¿Más preguntas por acá?
Please don't forget to raise your hand so we can bring you the mic over.
Hi, I was wondering, like, you
Hola.
have a blog and everything,
¿Tú tienes?
and it's more like, how do you manage your time?
That's a great question. Thanks for asking.
Yes.
I don't know. I'm still figuring it out. Okay, so this is what I found to be really helpful are to-do lists. Like the only way that I can manage my time and do everything I do with a full-time job are to-do lists. I have a bullet journal, which I keep like really consistent to-do lists. Every Sunday night, I write my weekly to-do list. I do a review. I actually did this online for 3 years on GitHub. I did a personal goals repo that I kept until 2 months ago. So 3 years of my life you can find on GitHub if you really look for it. It's one of my top repos. It's kind of weird people follow it. But to-do lists, writing things down. Every Monday I go to work and I write a Monday weekly to-do list and just check things off. If it's not written down, I'll forget to do it. So I need to have that in my life, and that's really it, to-do lists.
¿Más preguntas?
I'd like to speak in Spanish. I'm here, over here, right here. I really like teaching programming, but I'm really bad at drawing. So I should start by learning how to draw better and do sketching and videos maybe.
I don't think that you need to be an excellent artist to teach. Again, you can leverage emoji, other iconography, squares and shapes. The more you practice, the better you'll get. But I wouldn't wait to start until you're better at drawing. You'll never get started that way. Just start now. I too think video is very interesting and I want to learn it better, but that's, again, a whole other field. So continue to do what you're doing now while you learn. I think that's the best way.
Hi. First, I really love your talk because I'm learning about graphic facilitation right now, and I've been trying to apply those techniques when I'm learning, And one of the things that, maybe because I'm beginning with this, is that sometimes I get like, my mind gets blocked and I can think of a drawing and how to draw like a concept that I'm listening right now. And I don't know how you did when you were learning about this. I don't know if you felt the same. And how can I learn how to be more, maybe faster, or, when I'm trying to think about trying to convert all those words to maybe images. And I hope you can understand what I mean.
Yeah, that's a really good question. I totally relate, because I think what you were asking is, while you are learning, there's a lot of content to take in at the same time. Like, how do you take the time to stop and draw? I wouldn't do that. I would actually just continue your note-taking like you would, but then when you're studying, go back and do some illustrations, because that way you can help understand the text content that you've written more, and you can share that with your students, your fellow students. When I was in college, I took a JavaScript course that I ended up teaching like fake teacher hours, because that way everyone got more time to kind of hang out. We were all friends, and also we had more time to study, and it helped me to learn the concepts better too. So write your notes, draw it, and then share is my advice.
Tenemos tiempo para una última pregunta. Okay.
Hi, I'm Rodrigo. First of all, thanks. That's a very powerful concept, the one you have there. And I want to say this concept touches on sales, marketing, service experience. And I'm a proof of that. When I was choosing between clouds to implement my service, between Linode and DigitalOcean, I chose only DigitalOcean because of the documentation, only because of that. And how did you actually manage to pull inside DigitalOcean such a transformation in regards to the documentation? How did you do that? How did you convince the people? Because this concept translates into sales, marketing, service, user experience, etc. How did you convince them?
Well, it wasn't me convincing people. DigitalOcean from the start has sort of invested in simplicity, in UI, and in design. And because of that, we're able to reach more people. Like you said, the documentation is really good because we put time into making it simple. We put time into thinking about our user. And the people who write the documentation, they're not sysadmins. They're people who are trying to figure out how to use it just like anybody else. Or like reading books. Like, I've been to their desk, they have books stacked this high about Linux. And they're not even sysadmins. And I have so much respect for those people. And because of that, because they have a different perspective, they're able to teach other people how to use it a lot better. And then they can ask the sysadmins, like, is this right? And then they're like, oh, that's great. Thank you so much.
Thank you.